Assalamualaikum warahmatullahi wabarakatuh. Introduce, my name is Zizki Wahyudi. My class B NPM G1D 021052. Here I will read a book entitled Electromagnetic with text 2 to 3, given by Mr. Novalio Darata. Charge and current. Each particle in the universe carries with it a number of properties. These determine how the particle interacts with each of the four forces. For the force of gravity, this property is mass. For the force of electromagnetism, the property is called electric change. For the purpose of this course, we can think of electric charge as a real number Q R. Importantly, charge can be positive or negative. It can also be zero, in which case the particle is unaffected by the force of electromagnetism. The SI unit of charge is the coulomb, denoted by C. It is, like all SI units, a partial measure, convenient for human activity rather than informed by the underlying laws of the physics. We learn more about how the coulomb is defined in section 3.5. At a fundamental level, nature provides us with a bilateral unit of charge. This follows from the fact that charge is quantized. The charge of any particle in integral multiplet of the charge carried by the electron, which we denote as which E 1.60217650x 10 min 19 C. A much more natural unit would be to simply count charge as Q sum Ne with N and Z. Then electron have charge min 1, negative 1, while proton have charge positive 1, and neutron have charge 0, non-charged. If in the course we will bow to convention and start with SI units. And inside, the charge of quark is actually Q min E 3 and Q 2E 3. This doesn't change the spirit of the above discussion, since we call just change the basic unit. But apart from in extreme circumstances, quarks are confined inside proton and neutron, so we really have to worry about this. One of the key goals of the CHIS course is to move beyond the dynamic of point particles and also the dynamic of continuous objects known as field. To aid in this, it's useful to consider charge density V, X, and T, defined as charge per unit volume. The total charge Q in a given region V is simply Q RVD 3x Vx3. In mass situation, we will consider smooth charge densities which can be thought of as arising from averaging over many points, like particle, but on occasion we will return to the idea of a single partition of charge Q. Moving on some trajectory R by writing V sama dengan Q delta X mean R T, where the delta function ensures that all charge hit a point. More generally, we will need to describe the movement of charge from one place to another. This is captured by E quantity known as the current density, Gxt, defined as follows. For every surface, the integral I z z s j point d is coin the charge per unit time passing through s. Here the s is the unit normal to is. The quantity is called the current. In this sense, the current density in the current per unit area. The above is a rather indirect definition of the current. Current flux rate density. To get a more intuitive picture, consider a continuous charge distribution in which the velocity of a small volume at point x is giving b v x, t, then neglecting relativistic effect. The current density is g v. In particular, if a single particle is moving with velocity v r.t, the current density will be g q v delta 3 x min r t. This is illustrated in the figure where underlying charged particles known as real balls moving through the ball surface s. A simple example, consider electrons MOVA. The wire in a long model wire is a long cylinder of a cross-sectional area E as shown below. The electron move with velocity v parallel to the axis of the wire. In reality, the electron will have some distribution of speed. We take v to be here infinite velocity if there are an electron per unit volume at which charge q, then the charge density is v and q, and the current density is g and q v. The current itself is e g and r a. Through this course, the current density G plays a much more prominent role than the current E. For this reason, we will often refer to simply as the current, although we'll be more careful with the terminology when there is any possibility for confusion.